All right, sorry. Nice. Let us go back to what I was saying, right? So as I was saying there, if you had the square root of a by the square root of b, you can multiply the a and the b and put the root over it, right? So the square root of 20 could also be this. Square root of 20, we could break up 20 into 4 by 5, which is root 4 by root 5, right? Root 4 by root 5, root 4 is 2, so the answer is 2 root 5. So root 20 is the same as 2 root 5, okay? If you multiply root a by root a, that's a over root a is root a, because what you say, right? Let's say I gave you 5 over root 5 and you have to simplify that. Real simple. 5 is root 5 by root 5. This root 5 will cancel and you will end up with root 5. So you have to know the rules, right? If you have to rationalize, you have to simplify that, turn it into a rational fraction. What you do, you multiply by the conjugate of the denominator, right? So you change the plus sign into a minus sign. So for example, if I gave you 2 plus root 3 over 4 minus root 3, to simplify that, you multiply by the conjugate of the denominator. So here's minus, so you convert it to plus. 4 plus root 3 over 4 plus root 3. And you multiply it out. Right? I'll do this as an example, just to help you remember. So you're multiplying the top. That'll be 2 plus root 3 by 4 plus root 3. All over the denominator. 4 minus root 3 by 4 plus root 3. Right? So the denominator, what you do, you multiply the 4 by the 4. That'll give you 16. Root 3 by root 3, that's 3. And you're good to go. The numerator, on the other hand, is 2 by 4, that's 8. 2 by root 3, that's positive 2 root 3. Root 3 by 4, that's 4 root 3. Root 3 by root 3 is plus 3. Then when you reach it, when you reach there, 16 minus 3, 13, 8 plus 3, 11. 2 root 3 plus 4 root 3 is 6 of them, right? So that's 6 root 3. Right? So there's some quick things to remember when it comes to rationalizing, right? Are you okay with that? All right, and then of course we have the log rules, right? The log rules, let's run through the log rules. Before we do the log rules, we need to remember how to go from exponent to log, right? So what you do, the A becomes the base, the C becomes the answer, and the B becomes what you find the log of. Quick example, if you have 2 to the x is equal to 5, right? And you convert this to log, the 2 becomes the base, the 5 is what you're finding the log of, and x is the answer. That's okay? Right? While we're here, how do we solve questions like this? Some questions we could convert them to the same base. Some questions we can't. In a case like this, we can't put it to the same base. So what you do? Calculator, no? What you do is you just take logs on both sides, right? And then make x is subject to the formula. All right? Here, we have the rules for logs. We have the rules for logs. Same. Log of the same value is 1. Log of 1 is 0. The n could go in front as a power, right? The n could go in front as a power. So you can take the power and put it in front. Like, for example, log to the base 2 of 2 cubed. The 3 could go in front. And we know that log 2 is 1. Right? Here we have log, same base, addition sign, so you multiply m by n. Same base, subtract sign, you divide it. Right? So knowing the rules is the first step to being able to answer questions, right? That's okay? So that's the rules there. So the rules in your summary, try to memorize them and go through them, right? This linear reduction thing is important as well. You have to sometimes be able to use logs to write an equation in the form y is mx plus c. So if I give you y is equal to abx, you take logs on both sides and then simplify to get y, x, gradient, and c. This here is real important, yeah? Your capital Y and your X must never have unknowns. So your unknowns here are A and B. So Y must never have A and B in it. X must never have A and B in it. And the converse is true. The gradient must never have Y and X. Y-intercept must never have Y and X. Okay? So we're going to do a few examples in each. All right? What you have to tell me is look at the question and tell me how you think we're going to solve it, right? So let's start easy. Right? Let's start simple, right? 2 to the x is equal to 4. How are we going to solve something like that? Try it. If you can do it, go right ahead. That's good. How are we going to attempt something like this, Shannon? Right? So Shannon said to take logs on both sides. Nothing wrong with that, you know. If you take logs on both sides, it'll work. But there's an easier way. What's the easier way? Put them to the same basis. Very good, Ariana. So you have to check that first. Make sure you can put them to the same base, right? So 4 is 2 squared. And now we have the same base on both sides. So we could say x is 2. Okay? All right, copy it down. Try this next one here. 3 to the x plus 1 is equal to 27x. Solve for x there. Solve 2 of them. Number 2 and number 3. Right? These are exercises. I want you to try. Don't wait on me to write the answer, right? Be like that, sure. All of the time. Right, I'm mixing up the questions, right? Some easy to hard, right? Can we see what you have so far, Sean? Good. Sean, can we see what you have so far? Come and pass it. I try number 2 and 3, right? If you can't put them to the same base, then you won't be able to, then you won't be able to do that, right? I'm gonna try this one. So let u equal to that. What do you do with this? So you can't do that, right? Integration by substitution, everything must have u in it. Right? So when you replace u, this here, what do you do with that? How do you get rid of dx? How do you get rid of dx? You gotta differentiate this and make dx subject formula. Right? We do the same one on the all night up. Anyway, so you do that wrong, right? So differentiate that and replace dx in terms of du, and then things will cancel. You don't have to say that. What's B part 1? Where's this? But I see, so why for B?
Is 20.
I do not. I just place my area. Huh? French. And what's the limits? You gotta solve it. I don't want it. I don't know limits. You gotta solve it. All right, let's see what you got. All right, so we're just looking for examples here. You're looking for some ideas, right? So number two, what technique we using here? Yes, Jacob, what technique we using? Logs on both sides, all right, that's wrong, but it can sometimes work if it's simplified properly, right? So the ideal technique here is to convert to the same base, right? But if you take logs on both sides, that's okay, you know. But you have to use the power rule and simplify it out. It will still work out, right? So here you will get when you compare, you'll end up with x plus 1 is 3x. Bring all the x on one side. So you'll get minus 2x is minus 1, x is a half. All right. Right, number 3 on the other hand, what we'll do here. Garage, how we'll attempt to solve number 3. Correct, Katrina? Notice when I convert 27, right, I should have had a bracket here to make sure, right? Right, just to make sure you expand it out properly. Because sometimes people make a mistake if it's 27x minus 1. But when they convert the 27 to 3 cubed, right, they don't put a bracket around the x minus 1. And instead of getting 3x minus 3, they get 3x minus. Good. Solve out 3. Tell me what you get. So as we already identified, we take in logs. Barrage it in. Segmenting. MB or MB mean? What does MB mean? My bad. Oh. Right, take logs on both sides and let me see what you get. Finish? Make it properly. It's how to be nice and no, this thing I not see nothing. This one. We like dancing. All right, so what you'll do here is take logs on both sides. So you'll get log 5 to the x is equal to log 6. Bring the x in front. Right, and then make x the subject of the formula. X is equal to log 6 over log 5. Right, log 6 over log 5, right? Remember, you have to carry the log 5 across. What's that? What's the log 6? What's log 6 by log 5? 0.11. Huh? 1.11. Okay with that? Right. So here I give you 3 different types, right? Well, 2 different types really. Our next type missing. Anybody remember? What's the next type of equation I could give you in terms of exponential? There's a next type that's missing. Anybody remember the next type? There's a next type of equation that's missing. Huh? With the what? The long one, huh? The one that could be a quadratic. Let's call it this guy's quadratic. Yeah? Let's call it this guy's quadratic, right? So let's see if we could get, let's see how we'll identify this guy's quadratic, right? Let's see if we could identify one that is book go clear. Where this book is jumping straight into the hard ones. Hold on, I'm trying to get one that's in between. And again, an in between. All right, let's check this one out. 3, 2 to the x plus 1 plus 3 x plus 2 is equal to 3 and a 2. Right. So you see this one here? Questions like this that have more than 2 terms, sometimes 3 and 4 terms, right? There's a way for us to convert it into a quadratic, right? So let's see if we can do that. Plus means what? Plus means multiplied, right? So 3 to the 2x plus 1 is the same as 3 to the 1 multiplied by 3 to the 2x. That makes sense? Yeah, Jaden? What do you think is 3 to the x plus 2? Yeah, are you? Thanks. Yeah, Jaden. Right, but 3 to the power 2. Very good. Right, minus 3 and 1/3. Right, 3 and 1/3. We can convert it. 3 and 1 is 9. 3 by 3 is 9 plus 1 10. What's the next step here? Yeah.
We could say well, left 3 to the 2x.
Very 3 to the 2x.
Well, 3 to the x.
Right, start with 3 to the x. We let 3 to the x be something like y. Okay, and then we know that 3 to the 2x is what? Y squared. So we have 3y squared plus 9y minus 10 on 3 is 0. And you can go take a calculator and solve that. Help me out, please. Go take a calculator and solve that quadratic. You have A, B, and C is just C a little way. How much you got for y? What you got for y? When you solve it. 1/3. And next value. Minus 3. Minus what? Minus 10/3. Something wrong. Anybody else got? And a calculator. How much you got? Let me see. I know yours could do it, sir. I'm sure yours could do it. Anybody else got our online? Don't forget this, sir. After you find y, put 3 to the. After you find y, 3 to the x is 1/3. 3 to the x is minus 10/3 and solve for x. This. And please. Come on. Mode equation. And into the quadratic number 3. Plug in A, 3 plus equal. Plug in B. Plug in C. That's minus. That's minus 10. The answer is minus 3.33, which is minus 10/2. I can do it. Right? And then get a plus more to come back out. Press mode, come down, equation. 2 variable, that's a quadratic, right? The action for A, the action for B, and the action for C. Right? 1/3 minus 3. Press back mode and go to 0. Nice. To finish it up. So you'll get 3 to the x is 3 to the minus 1, so x is minus 1. Right? 1/3 is 3 to the minus 1. What is minus 10/3? What is 3 to the x is minus 10/3? Anybody? 3 to the x is equal to minus 10/3. Anybody online have that? Yeah, online, you're here now. Can you find, is there any power of x that'll give you a negative value? Answer is no, right? Right, the exponent graph doesn't occur in negative side. Right, there's no value for x that'll give you a negative value here. So this is no solution. All right. What? How you get answer? You do it wrong. All right. Are you okay with that? So you cannot so you can't find e to the x. Well, x can never give you a negative value. That exponential graph doesn't occur when right, it doesn't exist on the negative side. Sorry, I drew the wrong one. That was log. Right, so the graph of y is a to the x looks like that. Has no negative values. Let's go again. Try that there, message your answers. Those who online, please book a little fast, right? So the faster you go, the more we can do, right? And message your answers. Daria, Nishana, Kayla, message your answers. Christian, everybody. Try this one, right? What type is this here? 3 terms, so you're looking like a what? Quadratic, right? Try that fast. All right, keep messaging the answers. Nice, good job. Right, what you're going to let y equals 3 to the power of x, right? And always remember the right hand side must be equal to what? The right hand side must equal to 0, right? Thank you. Dropping your pen and take some colors. That's true why come on from. Right? So it was true, right? Oh, wait, that was you. I thought that was this one. Yes, I was. Right, so your close to it, say that's instead of 3y is just 3. Right, seeing the answers coming in there. Christian, send the answers, huh? Yeah, check it out. You get 200.
It's okay. It's not true. It's like, it's a different. Yeah. You're pretty good. Yes. Yeah, pretty good. Yes, that is right. So you can have the
All right, sorry about that. So let's see, right? So I've seen some answers there. So this is 3 to the 2x minus 4 3 to the x plus 3 is 0. I'm going to let y equal to 3 to the x, right? And of course, we know y squared is 3 to the 2x. So you're going to get y squared minus 4y plus 3 is 0. When you solve it, you'll get y is 1 and y is 3. Correct? Correct, Olia? Yeah? Correct?
Yes, sir. I got that.
And then 3 to the x is 1, so x is 0. 3 to the x is 3, so x is 1. All right, nice. Good. So it gives us a little idea how to do the indices, right? Now let's shift to logs now. All right, let's ship it to logs. Take a little minute and look back at your rules. Look back at your rules for logs. Sorry, sir. You have the summary. You could do that. Sorry. What is shall learn it by now then? Huh? What? I shall book to spare. Nah, don't work in books in the pocket, huh? But some file for somebody else. Or some pages here I could use. Yeah, like some graphic where you can write back. Some graphic where you can write back. All right, nice. So let's take a look at some log type questions now. These are all the log rules here. All right. Okay, let's go. Let's start with this one here. Nice. So if I ask you to solve number 1, what's the answer? What is log to the base 10? X is how much here? Excuse me. Excuse me, still in my class.
So this one is my seat.
Yes, log to the base 10 of 10 is 1. Simple, right? Simple enough. Okay. What about number 2? What about log to the base 10 of x is 1?
Okay.
X is how much? 10, right? You can watch it. I just change around the x. Right, but how we could solve it though? How we could solve it? So what we could do is we could convert to exponential form. So what will this be in exponential form? Kilon. What will this be in exponential form? Hey, Kilon. What would it be in exponential form? Woo. Nice. Huh? Right. Yeah, Kilon. What do you think there? When I convert that to exponential form, what will it be? 10 to the power of, carry across the 1. 10 to the power of 1 is x. So x is 10. Okay. Try number 3 now. Log to the base 3 of 5 is equal to x. Wait, no, sorry. Wait, in the wrong place. X is here and here is 5. Solve for x, please. Solve for x, please. Excuse Sean. Hey, Sean, you come to sit? Sleep on your room, don't play game. Come on, finish your that. What's that? Yeah, you're tired from playing game. Can't be tired from pure maths. Can't be from that because you're barely in the summary yet. How great it feel around here. Oh yeah, we do how much time again? We have an hour. Yeah. So help me out here. help him out here, or let Jamie send his answer. Book it out. I'll actually answer this now. Oh, yeah, before I disconnect. I'll fill in. Hold on.
Yeah.
Yeah? Okay, then cool, you're good. You good? You good? Excuse 3 of them, 4 of them say they're good. Okay, come on, sit down in front here, warm. In front here, warm. Sorry? Good job, Shannon. Good job, Sahara. Good job, Katrina, Richard, Kayla, Alejandra, Jamie. Very good. Keep sending. Who ain't got yet? Who ain't got? Malini. I didn't get yours as yet. Darian, yours will come in a little half an hour. We took Barrage and Jaden. Don't forget me, Jaden. Good job, Darian. Good job, Ishana. Barrage, nice job. Right, so when it converts to exponential form, you'll get 3 to the power 5 is equal to x. Okay? And x is equal to 243. Number 4. Let's change it slightly. Log to the base 4 of 5x minus 4 is equal to 2. Oh yeah, try that there. Log to the base 4 of 5x minus 4 2. Hey, if you can't do it, just move on and go to number 1, 2, and 3. Right? Okay. Go back to 1, 2, and 3. Let me see it. Let me see how you do that. I say, ooh, I'm blinded by the light. Sorry, I will. Once I get here. All right, answers coming in nice. Nice, the answers coming in. That's what I like, right? All looking right so far. How much you get? Hey, good man. One second.
Still, I know when you start going to put it out.
So you know how I feel, right? Right, so you know how I feel. Hurry. Oh, they go freeze the deal. I'm going to wait a little more. It will freeze today. All right, we done? Jaden, how much you got? Right, online, any more answers? Jaden, I didn't get your answer online. No, next Jaden. Next Jaden, boy, one more online. Right, so let's see what you got. When it converts to exponential form, that'll be 4 to the power 2 is equal to 5x minus 4. This is 8. This is still 5x minus 4. Bring everything on one side. You'll get 5. Sorry. I'll leave in the 5x where it is, carrying across the 4. Oh, wait, that's 16. I make a mistake. Yeah, thanks, Sahara. So that's 16 minus 4, which is 12. Yeah, that was a 5, you know. All right, I will take my thing. I will take it. So x is 4. I will take it. I make a mistake at taking it. All right. Back and tell you, I ain't taking off the AC. All right, let's go again. Let's go again. I will leave you with this one, and you try it, and then I will jump in. All right, let's go. Well, I'm started, huh? All right, so let's try this one. Log to the base 3 of 2x plus 1 minus log to the base 3 of x minus 7 is 2. So I'll bring 2 logs now, right? So whenever you have 2 logs and a minus sign in the middle, what you do? 2 logs, log same base, right? Same base and minus sign in the middle. What you do? Yes, divided. Very good. Is divided, right? Let's see. Come back on. Copy down fast, right? Before I cut off again. So divide and then do your thing. Take your time when you're solving it, right? Playbook on top, not sure. Playbook on top. So you keep turning back. Tomorrow you will have a book to turn back, right? Put the book on top. You can put the passive or lower down if you want. All right, answers rolling in already. Kill on again, sure. Kill on. Hop on. Why on the phone? Kill your head. I'm gonna give you a hard one just now, right? Building up. Garage again, should I? Malini, are you there? Malini. Malini. All right, let's see how it went. So this will be log to the base 3. Subtract means divide, so that'll be 2x plus 1 divided by x minus 7 is equal to 2. Now we're going to do the same thing we did before. We're going to convert to exponential form. So that'll be 3 squared is equal to 2x plus 1 over x minus 7. Right? 3 squared is what? 9. So that's 9 over 1 by 2x plus 1 over. What's the next step? Two fractions equal signs. So you're going on what? Cross multiply, right? So you're multiplying 9. So you're multiplying 9 by x minus 7 and 1 by 2x plus 1. So you'll get 9x minus, what's that, 63? Is equal to 2x plus 1. Bring it across, you'll get 7x, carry it across, you'll get 64. So x is 64 and 7. Right, nice job, Alejandro. Where's Aishana? Right, Flores, check back in denominator there. Oh, no. Oh, you send it back. Okay, yeah. Darian, good. Alejandro, good. Copy down. Let's go on next one like it.
So you may see
Next one. All okay there? Right, going a little bit harder. Right, this one will be 2 log to the base 4x minus log to the base 4 of x plus 5 is equal to 2. A little bit harder, not much harder. I don't know. Try it and see. Finish? Right, so before, so I gave you a few minutes. What's the first thing to do here? What's the first thing to do here before it turns into the last one that we did? Some that we have to do. The both of them is the same base already.
So the two is the two.
All right, take the 2 in front. Take the 2 in front and make it the power. Right? So it's log to the base 4x squared minus log to the base 4. Now it looks like the one that we just did. Right? Now it looks like the one that we just did. Right? Copy it out. Work it out fast. Right, Sean? What's your fire reach? Machine number 1. Come with the book. Right, people finish already, so hurry. Yeah, we had within this. First part is finished up. Don't pass away to do other 1 and 2 for your lead. It's 10 to 5 already. Y'all done? Come with the exact thing from before. Same rule, everything. Plus 4. You can multiply, right? We never get to linearization yet. Right, nice. I've seen some good answers. Malini not there. All right, I'm gonna just call Malini parents. Aha, Malini short answer there. Katrina, nice. Richard, good. I gotta check the values, right? One thing though, and I forgot to mention it. When you get to X values, you have to put the X values back here. And if it's negative, like for example, if you got -2 and you put -2 there, you can't find log of a negative value. So yeah, you gotta be careful, right? You have to be careful when you're working them out. So this is log to the base 4 of x squared over x plus 4 is 2. I'm going to convert to exponential form. So I'll get 4 squared is x squared over x plus 4. Cross multiply, that'll give you 16 by x plus 4 is equal to x squared. So 16x plus what? 4 by 16 is how much? 64 is equal to x squared. I think you had 80, yeah? Oh, it's x plus 5. I write the wrong thing. That's not multiplication. I just wrote down the wrong thing. Right? So that's 5. That's 5. That's 5. That's 5. And that's 80. So now we have a quadratic. X squared minus 16x minus 80 is equal to 0. Right? When you solve, you got x to be minus 4 and 20. Right? The reason why we will ignore this solution here, the reason that we'll say this solution is not valid is because when the 2 is here, you're finding log of -4. Right? So you will say not valid, and the only solution there is 20. Okay? Because if you put -4 in here, you're finding log of a negative value, which will give you 0, which will give you error. So -4 is technically not a solution. All right. Let's try one more like this before I change the type, right? Take your time. I just adding on one more log term here. Anybody writing? Anybody writing there? Yeah. Okay. Yes. All right. I just line down to. Yeah, take it. All right. What boy when you call him? Yeah, I tell you yes about 5 times already. Next one. Last one. This is log to the base 10 this time of x squared minus 6. Log to the base 10 of 2 is equal to 1 of log to the base 10 of x. Go ahead, take your time. Every time you're doing a question, bring all the logs on one side and then work it out. Take your time. And so far you will reach. Yeah? Okay, then again, should So the first two steps are what? Log to the base 10 of x squared minus 6 plus log to the base 10 of 2 minus log to the base 10 of x is 1. So I brought all the logs on one side, right? Then plus means multiply, minus means divide. So that'll be log to the base 10 of x squared minus 6. I'm multiplying that by 2. No, don't ask no question. And then divide by, and then you divide them by x is equal to 1. Right? So I bring all the logs together, multiply it out, divide by x. Right? And then I'm going to convert, so that 10 to the 1 is 2x squared minus 12 on x. Cross multiply, and we'll get 2x squared minus 12, 10x. Then do your little thing, solve it quick. 10x squared minus 12, 2x squared minus 10x minus 12 is 0. And then you solve for x. How much you get? So what quadratic then? So I got 6 and minus 1, but this one is not valid, right? That's not valid. Anybody else got those values? 6 and, well, I saw somebody got 6. Nice. Right. But remember, minus 1 is not a valid solution, right? Right, we're gonna change the type now. We're gonna change the type. And then we'll do a quick run through on quadratics, right? Sorry, not quadratics, we'll do some remainder and factor. As it gives what? Try to do Star Wars. Try to do Star Wars. Wait, good. I'm telling you to watch it. Next one. No. Pass that way. Right side, I'm going to change just one more type. I want you to give me a little help here. How are we even going to start this? So look at it closely. Log to the base 2. Log to the base 2 of 4 plus x minus 5y is 0. That's equation 1. And I'm giving you our next equation. Log to the base 2 of x plus 1 is equal to 1 plus log to the base 2. Sorry, 1 plus 2 log to the base 2y. So you have two equations there. Are we attempting something like that? So you have two equations. Any ideas online? How are we going to solve for x and y there? Solve for x and y. Jaden, come up your phone, please. Right, nice. That could work, Darian. Anybody else online? How are we going to solve for x and y? We have two equations, right? So what we need. Right, good job, Ishana. So Ishana had to solve simultaneously. So we had to find a way to solve simultaneously there. Right? Right, we never really learn equations with log to solve. So what you should do is convert it. Convert equation 1 to something simpler. Convert equation 2 to something simpler as well. Half-five. Right? So take your time, Kilon. Convert it there. Simplify both equations. So you want to convert to exponential form, both of them. Then solve it simultaneously. So you're trying to get rid of the logs, right? Oh yeah, copy down pass point cut off. Oh yeah, we're not giving them much time, right? That way, if I give them trouble, so that's right, then on the board. So somewhere in the dark, get it clean, right? Right. So the problem here is that we had to solve this, right? And we can't really make anything in substitutory formula. So what we had to do, convert to exponential form, right? So if we take equation 1 and we convert to exponential form, we will get 2 to the power 0 is equal to 4 plus x minus 5y. Same thing we do now time. 2 to the 0 is 1. And we can make x the subject of the formula here. That'll be 1 minus 4 plus 5y is x. Right? So it means that 5y minus 3 is x. Okay? That is your equation 1. Well, technically your equation 3 there. Hey, what were you doing? Right, so you have one equation, you have to get a next equation here and then solve simultaneously. Oh yeah, try that quick. Right, so once you get your answers online, send it, right? Oh wait, somebody get it already? Nice job. Check it back at Ara. All right, so that's what you have. That's the way it did here now. So now you have to convert this one to an finite equation. That's 2, right? So you will see from equation 2, bring all the logs on one side, log to the base 2 minus 2. Right, I'm moving this 2 one time, right? So this 2 becomes y squared is equal to 1. So when you work this out, this will become log to the base 2 x plus 1 on y squared is equal to 1. Right, nice. And I'm going to convert this to exponential form. Right, and then convert this to exponential form. So we will end up with 2 to the power 1 is x plus 1 y squared. Multiply it out. x plus 1 is equal to 2y squared. Right, now I have two equations that I can easily solve. So I can solve equation 3 and 4. All right, so I'm going to put x in here. So that's 5y minus 3 plus 1 is 2y squared. I have a quadratic, so I'll get 2y squared minus 5y plus 2 is 0. Come to calculator, what you got there? Anybody have that in? Right, so I have 2 minus 5. So I have 2.5. So my two answers for this whole thing, the x values are 2.5, the y values are 2.5. When y is 2. Right, when y is 2, x is equal to 5 by 2 minus 3, which is 7. And when y is a half, x is equal to 5 by a half minus 3. Right, so that's what 2.5, that's a half. So our two answers are 7 and 2, and a half a half. Let's see if anybody got that. Huh? What? What? Yeah, you might get this. Oh, this is part of it. That's solving simultaneous, but yeah. But you just get logs. No. Real come from. Oh no. Right. Show them so you copy it down, and then let's try one with an exponent, right? Where we have to linearize. Okay, you have one more like this. Yeah, take a last one like this. I didn't see you'll get this one wrong. Actually, copy that down and let's do linearization, right? Huh? Right, I'll have to make a decision. I know, I already talked to you, if you don't want to try it for yourself. All right, so next thing that we had to look at, last thing, is questions that you have to linearize, right? So sometimes we will get something like this. So let's say y is equal to ab to the power of x, and they want us to linearize, right? Linearize simply means that we have to write this in a straight line form. The straight line is y is equal to mx plus 6. If you were to plot this, you will get a straight line. If you plot this, you'll get curve. So to linearize, what you do is you take log on both sides. Sometimes it's hard to draw this, but I can't do a drawing exam today. So take logs on both sides. So you take log y is equal to log ab to the x. Right, as I said earlier, please go online and use the videos as well. Go over the work, right? Right? So you have indices, go over and look over indices, right? Anyway, watch this here. So linearize means we have to write in this form. So we take logs on both sides, and we will get log y is equal to log a plus log b to the power of x. Okay. Right, so we take logs on both sides, we break it up, right? And now here's how go right. Let's take a look here. You'll have this exact thing in your notes already, right? So you take logs on both sides, and when you take logs on both sides, you want to get y is mx plus c. Remember the rule I told you? Y and x must not have what? Y and x must not have the variables in it, a and b. And m and c must not have y and x in it. So when I expand this out, I can bring the x down, right? So I'll get log y is equal to x log b plus log e. This here is good. That's the y. There is no a and b here. Which one here is gradient and which one is x? Which one here will be the x and which will be the gradient? This will be the gradient, right? Because it has no x in it, and this will be the x-axis. And this will be a y-intercept. So if you have to go and plot this now, what you're going to plot is this versus this. So you're going to plot log y versus x. So the question will give you x values and y values. Right? You're not plotting y, so you have to go and find log y. When you plot, you'll get a straight line. Right? From that straight line, the gradient, you have to work out the gradient manually, right? Work out the gradient, and that'll be equal to log b. Okay, and then your y-intercept here will be a c, which is log a. Okay, so the question will be, can you find a and b? And to find a and b, you have to find what graph to plot. So the first thing you will do is you'll take this, linearize it, then plot the appropriate graph. Plot log y versus log x. Then when you're done, find the gradient, make it equal to log b. Gradient equals to log b. Right? And then when you're done, you can find b. When you finish, read off the y-intercept and you'll get log e. Okay? So these questions are general, define a and b. Right? So have a few minutes. Try this one here for now. Y is equal to p at x to the power of q. Try and linearize it and tell me what's a plot. Those are the two popular ones. We have others there, but those are the two most popular. Okay, try that there. Linearize that for now. So I want you to tell me what's the y-axis, what's the x-axis, and what's the x, what's the y, what's the gradient, and what's the y. Try that fast. We're not looking back here. That's not minus sign at one, right? That is log pxq. Sorry. Right? As there's a little thing on the board there. Come back to 2 or something. Right, so that's px to the power of q. So linearize it. Let's see what you have. Right, so I want you to linearize that, right? So for homework, look at the videos, go through the topics, right? And on Friday and Saturday, when you come, we'll take a look at your topics you get in trouble with, right?
What time? Maybe let's run by. Friday,
Friday is the last 5, Saturday is 12. Huh? Hurry up, linearize that and what you get. Are you done? Right, come on, go and do this. Come, Jacob, come on, go and do it.
It's true.
Come on. Do you think pass now, boy? On. I'll take it off. I'll take it off. Right, online message for what you got, right? Message quickly what you got for right, Jamian. Good job. Yeah, good job, Jamian. Hey, come pass away. You don't know who messaging now? Me? Hey, come pass now. All right, I'll take it too long. So you take logs on both sides, you'll get log y is equal to log p x q. Right? So this will be log y is equal to log p, multiply means plus, log x to the power q. Right? You bring the q in front, and you'll get log y is equal to q log x plus log p. This is your y, this is a gradient, this is your x, this is your c. So the graph diagram plotters, the graph that you're going to plot is log y versus log x, right? And the y-intercept is log p, and the gradient is q. Okay, that's what you'll get. Sometimes you have to draw the graph on it, right? All right. So for today, we got to revise indices and logs, right? Right, tomorrow we revise some math topics, to revise some physics, Saturday revise whatever you want, and Friday whatever you want. So Friday and Saturday is more individual, right? All right, online Friday and Saturday is more individual, but it had to be face to face, right? Right, so Friday is 3:30 to 5 or before 5:30, I mean, and Saturday is till 12:30, 8:30. No. All right, online. So that's it. You all could log out, right? All right, you all could log out. Bye.
You want to drop one? Eu want to drop one, boy.
Sei lá, eu estudei assim.
You going away? Coming tomorrow? No, they come Tuesday. You have to pay first thing. When it comes Tuesday, just go straight down and pay. You learn to put something in there.